My name is Kristen Riedinger, and I'm here to tell you about the impact and importance of nitrosamines in drinking water. Having access to clean drinking water is an essential part of day-to-day human life, but it takes a lot of work to make sure that this water is safe enough to drink. About 120 years ago, municipal treatment plants in the United States started adding chlorine to their drinking water in order to get rid of harmful bacteria. This strategy led to a huge reduction in the number of deaths from dangerous diseases like cholera and typhoid. This was a huge win for public health. However, around 50 years ago, we realized there was a slight catch to this solution. Adding chlorine to drinking water can lead to the formation of disinfection byproducts, which are chemicals that can form in small amounts when the chlorine reacts with existing material in the water. Some of these disinfection byproducts can be toxic. Nitrosamines are a group of disinfection byproducts that are found all around our environment at low levels. Some studies have shown that certain nitrosamines can cause cancer in animals. One nitrosamine of particular interest is N-nitrosodimethylamine, or NDMA, because of its high rates of detection and toxic effects. In addition to forming as disinfection byproducts, nitrosamines can also be created when hazardous materials get dumped into the environment and then leak into the groundwater. When people drink this groundwater from their water wells, it's possible to be exposed to these contaminants. My job is to figure out how much of these chemicals people are being exposed to in their drinking water and what might be making the problem worse. Because NDMA can be harmful, we need really strong analytical techniques in order to measure it properly and understand human exposure. I'm currently working on collecting water samples from a nearby community in Wilmington, Massachusetts that has suffered from the presence of NDMA in their groundwater historically, so that I can figure out whether they have nitrosamines in the water they're drinking today. I also want to uncover what factors might be contributing to the occurrence of these compounds, such as particular treatment techniques in water treatment plants or characteristics of the water like temperature or acidity. In order to more fully understand this problem, I'll be taking a large number of samples and using the most up-to-date methods to measure nitrosamines so I can identify potential patterns that could help us figure out what causes these compounds to form. This information should help us to better understand the current risks to human health and help develop treatment systems to eliminate such toxic substances from our drinking water so that communities have access to the clean, safe water that they need.